Hello everyone, today we're going to talk about naming molecular compounds. Now molecular compounds are named differently because we're not talking about positives and negatives anymore. We're talking about sharing electrons. These are also called covalently bonded compounds. They consist of non-metal atoms bonded together through shared electrons. So there's not a metal and a non-metal, it's just non-metals. To name them, we indicate the number of atoms of each element with a prefix before the element name. So I'm going to give you a second to write those down. Okay. When we name molecular compounds, for the first element, we use the Greek prefix and then the element name. For the second element, we use the Greek prefix, the element name's stem, and then the word "ide." Mono is never used on the first element name, only the second. So here we have some examples. The first two should look very familiar. Hopefully they help you remember some rules. So this first one, we have one carbon. We do not say mono if it's on the first one, so we just write carbon. For our second letter, we have two. Our prefix for two is di. So we have carbon dioxide. Okay. First, second example, we have one carbon and one oxygen. So again, we don't say mono on the first one. So it's just carbon. And then to say that there is only one oxygen, it's monoxide. Okay. Our next example, there are two of the phosphorus. So we say diphosphorus. Then there are five of the oxygen. So pentaoxide. Our next example, we have one of the sulfur. So it's just sulfur. We have six of the fluorine. So it's hexafluoride. Next example, we have one of the sulfur, so it's just sulfur. Three of the oxygen, trioxide. Okay. Next, we have one of the silicone, so it's just silicone. And then four of the bromine. And so four of the bromine is tetrabromide. Next, we have Xe, which is xenon. We have one of those, so it's just xenon. Six of the fluorine, so hexafluoride. Go ahead and pause the video, see if you can do the rest of them on your own, see how you're doing, kind of test yourself. Okay. Next, we have chlorine trifluoride. Next we have dichloride, heptaoxide, for our final example, we have tetraphosphorus, decoxide. Okay. Going from the chemical formula going from the name to the chemical formula. First, we get the elements, and then the number of atoms from the prefix. In our first example, we have phosphorus, so we know that's a P. Tetra is 4. Then we have sulfide, which is S, and hexa is 6. For our next one, we have bromine, di, okay, and then oxide, hepta. For our next one, we just have nitrogen, so that's 1 nitrogen, trichloride. For our last one, we have dinitrogen, pentasulfide. So penta is 5. Okay. Now these are a mixture of everything we've done so far. So you're going to need to know how to tell the difference between them, where to look for each one. It's going to be challenging. So in front of you, you should have out all of your resources, a periodic table, your polyatomic ion chart, everything. Okay. So our first example is BaCl2. And if you notice, Ba is from the left side of the periodic table and Cl2 is from the right side. So we know it's ionic. So we just list the name of the first element and then the name of the second element and change the ending to IDE. So our first one, barium chloride. Next we have AgF. If you notice, this Ag is in the middle on the D block, so we know it's a transition metal. So we know our written out compound is going to have parentheses with the charge. So we need to figure out what the charge is. Cross them up. That tells us Ag is +1, F is -1. Check the periodic table to make sure F is actually -1, which is correct. So Ag is silver. In parentheses, we write the charge of 1. And then fluoride. Next, we have CuSO3. First thing I notice is that copper is a transition metal. So same thing, it's going to have parentheses. Cross up the charges. Now, notice this SO3. SO3 is a polyatomic ion. So you need to look up the entire polyatomic ion's charge. This isn't saying that copper's charge is 3. It's saying that there is 1 of this whole ion, of the polyatomic ion. So copper's charge is +1. SO3's charge is -1. Then we need to check on our polyatomic ion list whether SO3 is actually -1. It is not. Its charge is -2. So we have to multiply our first one by 2. So we have copper with a charge of +2, and then sulfate. I'm wrong. Sulfite. Okay. Next, I have K2SO4. You'll notice K is on the right side and SO4 is a polyatomic ion. So cross those up. Make sure those are correct. They are indeed. So I just say potassium. It's on the left side of the periodic table. It is not a D block, so it does not get a parenthesis. And then SO4 is sulfate. Next, we have Fe and P. Fe is a transition metal. So I cross them up. That says that my charge on iron is +1. My charge on phosphorus is -1. Check that. It is incorrect. It should be -3. So I need to multiply by 3. When I write down my charge, iron, 3, phosphide. Next, we have nickel and then MnO4. Cross up my charges. You'll notice nickel is a transition metal. So I need to cross up my charges. This is saying that nickel is +1, and then MnO4 is -1. Checking the MnO4 manganate on your polyatomic ion list. It should be -2. So then I have to multiply this one by 2 to get +2. I'm going to write nickel with a parentheses and then 2. MnO4 is manganate. Okay. Next, I have CdOH2. Cd is found on the periodic table. It is a transition metal, so I have to cross up the charges. It's telling me Cd is +2, OH is -1. Check the charge on hydroxide. It is indeed -1. So we're going to write cadmium, parentheses 2, hydroxide. Okay, we did half of them, so you should pause right now. Try to figure out if you can do the other half on your own. See what you're missing, what you don't understand. Okay. Going through the right side now, I have NiBr2. Ni is a transition metal, so I'm going to cross those up. Ni, it's telling me is +2, Br -1. Check the Bromine, that is correct. So I have nickel, parentheses 2, bromide. Next I have SO2. S and O are both on the right side after the staircase, so therefore this is a covalent bonded compound. So we listed sulfur dioxide. In our next example, we have Pb. Pb is a transition metal because it's found in the middle of the periodic table. So we have to cross those charges up. Pb plus 2, Se minus 1. Check that Se is in fact minus 1. It is not. It's minus 3. So I have to multiply by 3 to get a charge of 6. So when I write this, it's going to be lead 6 selenide. Our next example is PF5. That P is on the right of the staircase, so they are both nonmetals. Therefore, we name these using the prefixes. So it's phosphorus, pentafluoride. Our next example is Cr. Which is chromium. Chromium is a transition metal, so I have to cross up the charges. Cr is plus 3, CHCOO, CH3, COO. That's acetate. If I look on my polyatomic ion sheet, acetate is at -1. It is indeed -1. So we write chromium 3 acetate. Next we have aluminum, which is again a transition metal. Cross our charges. It's telling me aluminum is plus 3, CO3 is minus 2. I need to check that. CO3 is carbonate. It's on your polyatomic ion sheet. It is in fact minus 2. So we write aluminum 3 carbonate. Okay. Last one, we have Mg and then N. Magnesium is all the way on the left-hand side of the periodic table. It is a representative element. So this is magnesium nitride. You guys have 2 worksheets today. One is having to do with just simply the prefixes and the covalent bonding. So that's one, the 2 nonmetals. And the other worksheet is a mix of all of them. Please let me know if you guys have any questions or I can help you in any way. Have a good day.